Hi everyone, this is Evgeny, and in this video we are checking how to build MCP server using Spring Boot and Spring AI frameworks. And specifically we are trying to create remote MCP server, so it should be interesting watch, I think. So let's check together. But before we dive into this topic, I wanted to say thank you to one of our supporters with the name Andrea. So Andrea, thank you a lot for your support, for being with us with the channel, for watching, for commenting. It really means a lot for us. Thank you again. All right, so what do we have here? I have already the project created. I'm going to go through it and explain different parts of it. And also another thing you need to know, there is a MCP server, or in general, Model Context Protocol documentation in Spring area. And the section we are interested in at the moment is the MCP server boot starter. And what you need to know that practically there are three ways how you would start your server. And this could be the standard server. So in general, based on the way you pick to start your server, you have to provide three different starters. And the easiest way probably would be the standard MCP server, and this is the one we saw already in the past. In general, this is the one that works completely on the machine, so on local machine. It's not a remote server, and the communication happens via standard input-output protocol streams. And if you want to this, like the easiest option, then you add the Spring AI MCP server Spring Boot starter. The more complex option would be to use Web MVC server transport, and here we're using another starter which supports this SSE server sends events protocol kind of. And additionally, the beauty of this approach, for example, it's based on the configuration, so there is an optional STDIO transport as well. So based on the configuration, for example, you can have your application, but then on the startup time you can decide which protocol you have to support, like is it a local server or running remotely. So this is the beauty of this solution. And the third thing you can use is WebFlux, and this is the same. It's a remote server but with a reactive approach, keep it in mind. And the same optional STDIO is possible here. And when you add one of these three starter dependencies, they add a lot of default beans, and they configure your MCP server automatically for a specific use case. So if you check it here, I decided to go the middle way. So what we have here is main point. We have the Spring AI starter MCP server Web MVC. All right, and practically I think that's enough for a very simple use case where you want your MCP started and running. So what do we have here? We have the application itself, and here we need to define a specific bean that would provide a tool. So we have this tool callback provider, and this one takes our service that's responsible for performing the tool in reality. And then we have the builder, we build it, we provide the tool objects, and we return it back, and that's it, right? Practically that would be enough. The only thing that is missing at the moment, we need to document your tool, so it's possible for the model to understand better the reason of this tool to exist. And so if you go to this RAG service, in our case, we can see that, okay, we have this. First of all, this is a Spring bean, so it will be discovered by Spring and created on the startup time. And then we have this tool notation, and this one comes from Spring Framework AI tool annotation thing. And this one defines the definition of the function. So it goes directly to the model, and during the registration time, and it happens, it helps the model to understand better the reason of this function to exist. And what currently we are doing, like if you check the code, we have the search string query, and we are kind of simulating a very simple RAG system where we are trying to enrich our prompt with additional information, and we store it in the files. So what this tool is doing, it's taking the query and then it goes through all the files, and using the regexp, it tries to find all the occurrences in the file and returning back snippets where it was found. It's pretty simple, pretty easy. I'm not going to go through it because it does not relate directly to MCP, right? You can put whatever you want here, just something very useful that, like a tool that makes sense to provide, right? All right, what else is interesting here is our properties file, and this is application YAML at this time. And the same thing, if you want to know what kind of parameters you should set up here, you can go back to the documentation and scroll it till the configuration properties and take a look what we have here. First of all, we have several possibilities what MCP server can return us back. So there's resources, tools, prompts, or completions. And I'm not going to discuss it a lot, just generally. At this time, most of the clients, MCP clients, support only tooling. So this and this and this are for future. And you probably, for example, if you would implement completions or prompts, or you can return resources, for example, in your windsurf or cursor, it's not possible to reuse this. So it's only for future. Now we're using tools. And we even have the possibility of dynamic sending notifications if something is changed. For example, if you updated your tool list on the server dynamically, then you can send a notification to the client, and the client is aware that it has to recheck the tool list, for example. Right? And here we have it in capabilities. So we define in tools, we enable tools, and the rest is disabled, just to not confuse us and the client. We are using synchronous type of connection, and this is because we're using MVC. So for the case of Flux, it will be asynchronous. We have a lot of parameters by default, and then we are defining SSE endpoint and message endpoint. These are also by default, like if you check it here. So it's MCP messages and SSE. And in general, I put it there just to have the opportunity to explain it to you. So how it works, basically when we run our server remotely, it exposes, or there are two channels from the client to server and back. And the way how it works, when the model or client of this MCP server connects to MCP server, it listens on this SSE endpoint, and this is streaming. So this is practically what MCP server tells back to the model. And when model wants to run a tool, for example, then it uses this endpoint, MCP messages, and kind of asks to run specific tool, provide a list of parameters and all this kind of stuff. And once the MCP server receives the message here that the tool should be executed, it starts the execution and then sends the results back on the streaming endpoint here. So this is how communication happens. And in case of asynchronous communication, it's even better, right? Because you don't have to wait until your tool is finished. And once you start streaming something back to the client or the model can start processing your output directly without waiting to this tool to finish. So that's the raw idea. And for our rack system, kind of for showcase, just to demonstrate how it works, I created this rack folder and I put there markdown files that practically describing this documentation. I guess it's time to give it a try, and since this is a normal Spring Boot application, we can just simply run it, and it automatically provides the remote MCP server. I can click here, it doesn't matter, or we can use the plugin, and I'm running it. And look at that. At the startup time, we have one tool registered, and then practically that's it. Okay, and we have enabled tool capabilities. So we have only tools available for this MCP server. And interesting thing, since this is a normal Java application, it's pretty easy, you know that already, right? To deploy it on the production using like Docker, for example. And the same thing here, I have pair of Docker building and the Docker file, and you can create your own. Again, just keep in mind, this is a normal Java application. So whatever techniques you're using in your work with the deployment to production, they work here as well. And I just generated these two parts using AI agent to make it fast. And what we can do here, let me stop it. Let me rebuild the tool. So just this one is very strange. Anyway, Docker images here, and we can run it. And then port 8080 will be available. So again, you can configure to whatever you want. it's again up and running. It's exactly the same thing, right? And now we have it, your MCP server running remotely. Well, I think it's time to give it a try and check how it works. And the thing I would test first to use MCP Inspector. So I have a link here already, and we are using npx2 for that. Okay, there was an instance I ran previously when I was preparing for this video. Now we have it here. It's up and running on this kind of URL. And we can go here and just trigger it. So what do we have here? We have the protocol, and it's not local anymore, right? We have this SSE. And, well, maybe port is wrong, we need to fix it. Maybe we have to configure it in our Docker next time, so it's the proper one, the one by default, right? But nevertheless, we have it up and running locally on localhost. It should be available, and then we just connect into it, and we are there, right? And if you take a look at that, we have resources, prompts, and tools. It's clear sampling, I think was something else. But anyway, only tools are available because we enabled only tooling for this MCP server. And if I list all the tools, I can see this search. And this search across RAG documentation files for specific terms or phrases. This comes from the tool explanation, right? So if I go here, and where is my annotation? So it comes from this one, from the annotation. And we can type in query something like, for example, I don't know, MCP. Let's type, check something very easy and run it. And the result is success. Let's expect it again. And then we have a list of the results, and they are coming from our local file storage. All right, that was it for today. We went through the process of creating Spring Boot MCP Server, and we created remote one. And this is kind of a bit extra because, again, at the moment there are not so many tools that we can configure to use remote MCP servers. Probably it's a question of near future, but anyway, we checked how it worked. And in general, keep in mind that basically you have 3 ways how to run your MCP server using Spring. And this is standard input-output, the local server. Then you have 2 options for 2 remote options, like synchronous and asynchronous, for the normal MVC and for Flux. And the last 2 options, it's also possible to switch them back to local setup. And it was Evgeny, and I want to say thank you for all of you who watched this video till the end, and we'll see next time in the next videos about Spring, AI, and all this stuff around. See you, and bye-bye.